So what is the holographic principle?
Well, the holographic principle, there was that before the holographic principle, I have to tell you something about black hole entropy or black hole information storage.
The Bekenstein-Hawking entropy?
The Bekenstein-Hawking entropy, yeah.
Okay.
So Bekenstein and Hawking, and actually Wheeler was Bekenstein's thesis advisor, I think, yeah, and also involved in this, argued rather convincingly that black holes are capable, they can store a certain amount of information, and there's a formula for that, which is really that formula is one of the, well, I teach a freshman course in the laws of nature, and I try to teach, this is for non-physicists, and I teach them about three equations, which I regard as the most important, most interesting to be equations from 20th century physics. And they are the Einstein equation, Einstein equation of general relativity, the Schrodinger equation of quantum mechanics, and the Bekenstein-Hawking entropy formula. And that one, it's a very deep equation. We don't really fully understand it. We really don't fully understand it. And what it says is that the amount of information you can stuff into a black hole is proportional to the area of the event horizon. And that's a very strange thing because, if we wanted to, store information, put computer chips into this coffee cup, the amount of information we could store would be proportional to the volume of this coffee cup.
Yeah.
Not the surface area. Right. Somehow, if you could only tag them onto the surface, tile them onto the surface, then the amount of information would be proportional to the area. So that is very strange. And it suggests, in this case, that the region of space inside the black hole is described by some more ordinary system. Clearly, the black hole isn't an ordinary object, but it might be describable by an ordinary object that just lived on the surface. And that is the so-called holographic plate, right? That would be the holographic plate. The black hole itself would be the emergent hologram. So it suggests the hypothesis that any region of space-time, or physicists have slowly been getting interested in, and the idea that any region of space-time can be described, not just the interior of a black hole, described by some quantum system that lives on its boundary. Now, this sounds, forget about whether it describes the real universe or not that we live in, it sounds wacko. However, using various tricks in string theory, we've been able to show that we've been able to find some situations where exactly this happens. So the first example was in string theory was where Vafa and I showed that certain kinds of black holes were described by some other object that lived on the surface of that black hole, a conformal field theory. And that was then generalized by Moldacena to whole universes, so-called anti-de Sitter universes. They don't look like our own universe, but they are solutions of the Einstein equations, so on. This is all within string theory. They can be described holographically by something that lives on the boundary.